Hey y'all, welcome to part 1 of my series on V-carving for the absolute beginner. Now, before I get started, let me say that I am in no way sponsored nor endorsed by Vectric Limited nor any router bit company or manufacturer that I may mention. I'm doing this series to help the person who has never done this before learn the V-carving process, understand a little bit about the router bits involved, and create and finish a V-carve project within the CAD/CAM software. I'm going to be talking about V-carve Pro during this presentation because that's the software I use. But everything I'm going to show you in this series applies equally to V-carve Desktop, V-carve Pro, and Aspire. So with that out of the way, let me start by saying to some of the more experienced users, some of the seasoned veterans out there, that some of this that you're going to see will be old news. You already know a lot of this. Again, I'm doing this for the absolute beginner. So I'll ask you to please remember that none of us were born knowing this information. We all had to learn it somewhere. So if you'll just keep that in mind, I'd appreciate it. To the absolute beginner, I'm here to help you try to understand a little bit how this process works, help you with bit selection, and help you get going in V-carving. If you have any questions or comments, feel free to leave them in the comment section or contact me through my website, and I'll get into that a little bit more later on. So, taking the advice of Lewis Carroll, we can go ahead and begin at the beginning. And use this to illustrate something that I see come up a lot, and that is the difference in the various router bits. Now here we have a 90-degree V-bit, and here we have a 60-degree V-bit. The main thing to remember about these bits is that the higher the number, the more shallow the angle. Now this bit as measured from this corner here to the tip, and then this tip to this corner here, that angle is 90 degrees. On the other side over here, measured from this corner here to the tip, and then from the tip down to this corner here, is 60 degrees. The rule of thumb to remember: the larger the number, the more shallow the angle. The smaller the number, the steeper the angle. Okay? And when we talk about cutting diameter, what we mean is the diameter from this corner here to this corner here on the V-bit. These carbide cutters here will cut this V shape from here to here. Same thing with the 60 degree. From this corner here to this corner here. That is the widest these bits will cut. That'll become important a little bit later on. Probably the first place to start is, why would we want to use V-carving in the first place? Well, that answer can be summed up in 2 words: square corners. As you can see in this photograph here of a simulation in V-carve, if we were to pocket out a square with just a standard 1/4 inch end mill, for example, the bit has a radius. It is a round bit, and when it gets over here in these corners, it's going to cut that radius. It's going to machine the radius of the bit, whatever that may be. Using a V-bit, however, it will not only machine out the entire area, but it'll also add this chamfered detail and take advantage of the Z-axis to create these sharp corners. Up here, what would happen is, depending upon your toolpathing strategy, the bit would plunge down into the center if you're using the offset strategy, and start hollowing out this area here until it got to the profile pass, in which case it would come around and clean up, leaving these rounded corners. If you were using the raster strategy, it would move back and forth to hollow out this pocket, and then do a final profile pass to clean it up. With the V-carve, what it will do is use a large area clearance tool to machine out the bulk of the material here, just the same as this one. Then you would do a tool change, add your V-bit, and it do the profile pass here. But when it gets to one of these corners, the X and Y will start moving outwards while the Z raises, which will give us this nice square corner here and this faceted appearance. So that's how the machine reacts to a V-carve toolpath. Now, one of the more common questions I get is related to the depth of cut in a V-carve situation. Let's take a look at this in the context of carving text. I have an illustration here to show you what I'm talking about. This is a representation of a 90-degree V-bit and a 60-degree V-bit. Here and here are the same. One of the determining factors on how deep a V-bit will cut is the width of the space between the vectors you're attempting to cut out. If we have, for example, this simple text right here, capital I and a capital O, the V-bit in a V-carve toolpath is going to carve away all the material inside these vectors. It's not going to cut on the vector. It's going to cut inside the vectors. It's going to carve away all the material here until the edges of that V-bit are riding along this vector here and this vector here. It's this space between this vector and this vector, as well as the angle of the bit that's going to decide that cutting depth. In this instance here, if a 90-degree V-bit and a 60-degree V-bit are attempting to cut to the same half-inch width, the 60-degree V-bit is going to cut approximately twice as deep as that 90-degree V-bit. So it's the width in between the two vectors that you're trying to machine out, as well as the angle of the bit that's going to decide how deep that bit cuts. Now, there are ways you can control the depth of cut, but we'll get into that in a later video. When it comes to bit selection, just know that the steeper the angle of the bit, the deeper it's going to cut to get the same width as a bit of a shallower angle. So, to demonstrate that, what I'll do is I'll take this capital I and this capital O, and I'm going to calculate a couple of tool paths for them to show you the difference. Now, another thing to pay attention to, I said the distance between this vector here and this vector here, that also means the distance between them over here, and the distance between this vector here and this vector here. V-carving is considered by some to be 2.5 dimensional carving, and by others to be 3-dimensional carving, meaning that all 3 axes work at the same time to carve out this area here. Let me go ahead and calculate the toolpath and I'll show you exactly what I mean. So I'll select the text here. We'll go over to the toolpath tab, and I'm going to go down here to the VCarve/engraving toolpath. Select that, and we're going to put our start depth will be 0. We are going to start at the top surface of the material. When V-carving, always set your Z0 to the top of the material. So I'm going to use a start depth of 0. I'm not going to use a flat depth. We'll get into that in another video. The V-bit I'm going to use for this demonstration is a 90-degree V-bit with a 1/2 inch cutting diameter. I'm not going to make any changes here at all. I'm simply going to call this V-carve 90 degree, and we'll calculate. Now we have our toolpaths created, and if you notice, it looks a little bit different than what we would imagine. If we get over here into the O, we see it's going to have to make a couple of passes at different depths. I'm going to leave the material alone. I will select the toolpath, color, black. Well, that jumped to pine. Okay, fine. And we'll preview this toolpath. And as you can see, when we get in here and zoom in a little bit, our tool carved a straight line down here at a depth. Then when it got to this corner, it made a curved pass, and the Z kicked in and retracted that bit to make this nice narrow portion in here. Then it came back, lifted up here to make that square corner, lifted up here to make that square corner. By the same token, you get over here and look at this O, because we have a wider area here between this outside and the inside of that O. We cut pretty deep here. Then as this vector narrowed down, the Z kicked in and lifted that bit up, and we cut much shallower here. Now if you recall from the other tutorials that we did, if we look down here at my display, my X, Y, and Z0 display here, or Z display here, you can see my Z is at 0 because it's on the material surface. But when I come over here and drop that pointer down into this trench, for lack of a better term, we can see that it cut almost 1/4 inch into the material. We're at negative 0.2467. Almost 1/4 inch into the material. That was so the edges of this bit could get in and ride the edges of those vectors. If we go over here to the letter I, we can see that about the same, a little bit less, 0.2069. So that's how deep it had to plunge to get these real wide areas. Now if you watch the letter O here, as those vectors get closer and closer together, the depth on my Z gets shallower and shallower and shallower till we get up here to the top, and we're just a little over 1/16 of an inch deep. My point in all of this is that it's a combination of the width of the space between the vectors and the angle of the V-bit that dictate how deep that bit is going to cut in order to do the V carving that we want it to do. Let me reset my preview. I'll close that and we'll go back into the 2D view. They are still selected. I'll do another V-carve and engraving toolpath, but this time I'll switch over to a 60-degree V-bit with a 1/2 inch cutting diameter. Make no changes. Make no changes here except to call this 60 degree. Calculate. And already we can see a little bit of a difference. To carve the letter I, it's going to have to do it in a couple of passes. To carve the letter O, it's going to have to make 2 or 3 passes. So let's go ahead and preview this toolpath. We'll set my toolpath color to black. And we'll preview that toolpath. Again, we got a good result. But when we zoom in, keeping an eye down here on our Z readout, we can see that in order to carve this letter O, it had to go 42 thousandths, 4250, 4273, almost 43 thousandths of an inch deep to carve this letter O. Or excuse me, not 43 thousandths, 43 tenths, 423. Well, that's on 426 thousandths. So you get my drift. If our material is a 1/2 inch thick, we have machined almost we've machined a little over 2/3 of the way through that material to get this width out of a 60-degree V-bit. If we come over here to the letter I, we're a lot better off. We're at 356 thousandths. We're over 1/4 of an inch deep, but we're not quite 3/8 of an inch deep. For a situation like this, I think we would be better served running the 90-degree V-bit rather than the 60-degree, just simply because we can still get our width without carvings as deeply into the material. And this is something that will come with experience, knowing when to use which bit. And this is the time to experiment. Now we know that this is going to cut about 2/3 of the way through the material. That's probably not our best way to go. I'll reset the preview and I'm going to delete that toolpath. If I were going to carve this, I would use the 90-degree V-bit, where I know I'm only going to carve about 1/4 of an inch deep, maybe a little more, maybe a little less. Text size, or the size of the object that you are carving out, will help dictate which bit you should use. Now, if I select this and go back into my text editor, we can see I just have the I and the O here. Well, my text height is 3 inches tall. If I were going to carve anything 4.5 inches or larger, I might want to switch over to a 120-degree bit, so it carves even shallower than this. If I were going to make this 1/4 of an inch tall, or text height, I might want to switch to a 30-degree bit so that it carves deeper, so that we don't lose any detail if we sand. That's a lot of information to take in on the first outing. the takeaways I hope you get from this are, it's the bit angle, the width of the area that you're attempting to cut, that determine the depth of that cut. The lower the number on your angle of your bits, the steeper the angle is, the higher the number, the shallower it is. So I think we'll call this the end to the introductory video to this series. In the next video, we'll get into V-carving a simple text sign. Then in future videos, we will get into carving to a flat depth and maybe doing some pictures. We'll end this one here if you'd like to continue to follow this series, or if you'd like to follow along with some of my other CNC adventures. I do hope you'll subscribe to my channel. Now, if you have any questions, comments, concerns at all, feel free to leave me a comment down in the comment section. Now, if you'd really rather not leave a public comment, head on over here to my website, marklindseycnc.com, and click on this Contact Us link right here. You can send me any comment you'd like, and I will receive it via email. And I do read every comment I receive and try to answer every single one of them. While you're over here, take a look in the shop and you'll find I have a few DXF file downloads here that are absolutely free. And of course, you can check out my coffee cups and t-shirts if you're of a mind to. But there are some free CNC file downloads here in DXF format. MarkLindseyCNC.com is sponsored by Harneil Media, the web design company that specializes in website design and hosting for makers and the makers community. Harneil Media, as well as I, are both members of the Makers Media Network. So that'll wrap up this first episode. Again, I'd like to thank you very much for watching. If you got anything at all out of this video, please give me a thumbs up down below. And again, if you'd like to follow along in my CNC adventures, please hit that subscribe button and hit that bell button right next to it. That way you'll get a notification whenever I post a new video. Whether you subscribe to me or not, I'd like to thank you very much for taking the time to watch this video, and y'all take care.